Welcome, everybody. Excited to be here today, and I wanted to talk about a topic that's not just technical. I love going into the technical details, but oftentimes I get asked, how should I keep up with the AI space? How do I form an opinion? How do I deal with these predictions that are happening? What is the impact on me? So that's going to be my focus for today, about forming an AI opinion with asymmetric information. Questions I get is, how do you keep up to date with AI developments? I get this fairly often. We have meetups for this, right? We have conferences for this. We have papers and so forth. But it's a really interesting question. And typically, tell people, hey, read these research papers, go through these open source libraries, think about product news. But for a lot of people, that's still not enough. They ask, what's happening in the space, right? What is OpenAI going to do? What is Anthropic going to do? What is Google going to do? What are all these startups going to do? And I think the core question here is that we do as people have this fascination for AI gossip, right? When Meta was poaching all the researchers, there's the whole huge wave on LinkedIn and Twitter about this. So I think there's an inherent curiosity to try to stay in the loop, right, of what's happening, both from a career and sort of entertainment perspective. Now, this is something that happens because we have these major claims getting thrown all around, right? So Sam Altman made a claim on Reddit and later said that he was joking about AGI being achieved internally. We have the CEO, Dario, of Anthropic, who made a similar large claim that 90% of coding will be AI-driven. So as we hear all of these things and we think about how it's going to impact our lives, both from a career perspective, but also societal perspective, it's pretty anxiety inducing, right? So for this talk, I'll focus on some strategies that have worked for me and I think are quite useful. So the first part of the talk is about forming an AI opinion. So how do we figure out what's right in the world? It's a little bit of a philosophical question. So there's a range of opinions or claims that are made, right? We start on the left-hand side where these are just flat out lies that sometimes come out, right? People make things up all the time. And unfortunately, in the age of social media, these can be propagated around, right? So when people are getting excited about GPT-4 or GPT-5, right, people were making crazy diagrams, right, of how many parameters it has and other things with no basis in the information, right? It turns into a little bit of a rumor mill. And as we make our way over to the right, we get into this hype and sort of exaggeration phase. We get into marketing. We get into sort of releasing benchmarks. And then we get into, which is fairly rare, making very specific claims about what models can do or can't do. The other thing is that even if you have a claim that is specific and true, it's actually very hard to verify, right? Verify in the case of how it's run as an experiment, but also having the knowledge to know if this is true or useful. For example, at Microsoft Build 2024, they used this analogy of how much compute was used to train GPT-3, 4, and 5, with 5 being the whale over on the right-hand side. Now, this analogy is a great visual, but what does it actually mean, right? How do we verify this? Are we talking about weight, size, capability, parameters, right? It's actually really hard to do science communication and also interpret science communication when it's not specific. Now, with verification, it's also really difficult to actually know what the results are sometimes. If you've seen some of the news recently, we saw that both Gemini and OpenAI did very well at the ICBC, which is a undergrad programming competition. Now, I'm not a competitive programmer, and I assume many of you are not either, so it's actually very hard to verify what these results are. Many of them are not published, but even if they are, they sometimes go beyond our actual capabilities, right? Likewise, when something is applied to a different domain where you're not specialized in, you don't necessarily have the direct tools to make an evaluation and a concrete opinion. Now, for this talk, the goal is not to be skeptical of LLMs or GenAI. We've seen a lot of really good developments recently. Sora 2 came out, and it's very impressive work. If you showed that to somebody 5-10 years ago, they think you're pranking them, right? So I think it's important to acknowledge that the goal of this talk is not to be necessarily contrarian or LLM doomerist, right? But to figure out how do you actually process this information. Now, if we remember from 2023, there is a paper released and it sort of highlighted this idea of the jagged frontier, that LLMs aren't symmetrically good at things in the same way people are. So if you ask a person to walk around and they can do that, or if you ask them to work a desk job, you can probably transfer those skills to things that are something different, right? So I used to be a camp counselor. I used to work at McDonald's. The skills were different, but within a week, right, I could be a cashier at McDonald's with basic training. Now with LLMs, what we realize is that LLMs can be very good at very complex tasks like coding up a website, but often struggle with counting R's in strawberry or blueberry or other types of computation. So this makes it very difficult for us to actually comprehend because the capabilities are so different than our own. So this gets into this question of how do you actually communicate a model's capability? So if we look at the GPT-5 announcement, one of the key things that they had is examples of what GPT-5 could create. So they showed a few different games or technology capabilities to give people a visualization of what is possible with technology now. But what we know is that these are not production code environments, right? I'm not coding jumping ball runner every day, right? I'm debugging ML pipelines. I'm going through trying to understand prompts. I'm integrating systems together. So there's something imperfect about this, but it is a great visual and a way to see how far we've come, especially if it's done comparatively to previous versions. The next thing that we look at is benchmarks, right? So most releases of new models have benchmarks that we think about. And here are two examples. We have the GPQA and we have the Amy math competition. Now, these are great. They're showing that the numbers are going up with new models, which hopefully people expect. But it doesn't actually give us a good understanding unless we really dig into these benchmarks, what's happening. So for example, GPQA, it's PhD level science questions, but what does that mean to me as a person, right? I'm not a PhD or a researcher sort of in my primary job in biology or physics or something else, right? So it doesn't actually make sense for me to interpret this to my own life. But it does give me some point of view, and if numbers go up, right, that's generally good. So then we ask the question of what actually makes a good benchmark. And this is actually a very important skill to have, is not to just interpret numbers going up as something that's good. So again, this is where some of the critical thinking and diving deeper is really important, especially if you care about the AI space, is take a look actually what's in the benchmark. So SWE-bench is a very popular benchmark that came out at the end of 2023. And at the time, models were very bad at completing it. It was a set of GitHub issues that were being completed in Python with a distribution across different modules or different libraries. Now, even though this is a benchmark that appears in almost every release, if you look into it, a lot of the code is Django code and Django issues that people have on GitHub. And it's not completely clear what are the filtering mechanisms to actually remove these sample solutions or problems from the training sets. So from this perspective, we actually need to figure out how do we actually interpret these results both over time and between models. And when somebody makes a claim, hey, AI agents are here for coding, maybe they're here for specific Django tasks, but they're not here in general. So we need sort of a broader set of data or experiences to form a good opinion. So the third method I think that's interesting in communication is this idea of an analogy. So last year, we had this claim, right, made by the former OpenAI CTO that AI is going to have PhD level intelligence within the next year or so, right? And that's a very interesting way to phrase it because PhDs sound impressive to people, right? They sound important. They sound complex. Now, what happens with this claim is that it's not very specific, right? Because are we talking about developing new papers, solving equations, right? Reciting information. So we actually need to dive deeper into what this means, but it's a very illicit analogy. We also had this paper released or blog post called Situational Awareness. And this one was pretty interesting in talking about what is the growth of AI capabilities and using the analogy of different levels of education. So the first three talk about preschoolers, elementary schoolers, high schoolers, and eventually getting into AI researchers. Alec Redford was the GPT-1 paper author, and GPT-2. So in this case, the claim was that GPT-4 was at the level of a smart high schooler, but this is actually very hard to verify, right, with the jagged frontier and the non-specificity. GPT-4 could not count the number of R's in certain words, right? So is it actually at a high schooler level, or is it at a preschooler level? At the same time, it could write pretty elaborate poetry, right, which is at that level of capability. So it's actually very hard to verify some of these vague claims, and we have to be careful what analogies are being used and if there's additional caveats, right? Because to the media, it might be a 3-second soundbite, like PhD AI is here, right? But there might be a lot more nuance in the releases. And today we look at where we are in the claim, right? We would be somewhere here in the middle of GPT-4 and automated Alec Redford, but it's actually really hard to measure that because these claims are not specific. So from my perspective, I'm actually not sure where we are. We'd need a whole number of tests and specific criteria to verify that. So we know that LLMs are very good at coding and math. People are using them. There's a lot of investment into it, but it's unclear what it means for it to be at a PhD level. Now, going back to this question of how do we actually track progress and be aware and form an opinion, people struggle a lot with the concept of exponentials, right? So exponentials look linear at the beginning, and then they accelerate forward. And this is sort of the argument that a lot of AI researchers, I guess call them philosophers, are making, is that as we exponentially increase compute and make progress, we're going to see very rapid developments very quickly. So we went from LLMs coding reasonably well with GPT-4, like I was writing some SQL with it. Now it can outperform university students at coding competitions. So this is from a blog post published by Tim Urban in 2015, so a little while ago, and it sort of talks about this concept of intelligence and exponential growth, right? So the period of time for initial progress, and the argument in the blog post is that people make progress and it accumulates, right? We get the benefit of abstraction and general growth in the human collective. But if you look at the right-hand side here, and I made some artistic changes for if there's any children in the room, right? But if we think about time, right, the amount of time it takes to go from something very basic to more complex is very minimal. And that's the argument made by the situational awareness blog post and also various others. So this is something to keep in mind, that exponential growth, if something is actually exponential, approaches very quickly. We see this with various infections, right? COVID followed this pattern. We see this across the board, sometimes to your benefit if you have a investment portfolio that compounds exponentially, but sometimes against you if you have credit card debt, right? So just think about exponentials and can we actually model some of these behaviors in this way? Typically, when you think about software, we think about compute being cheap and easy to scale, but this isn't the case, right? So compute does have constraints. We're getting into the point where it's power constraints, not just chips. So we've probably seen a lot of claims about how much power we're going to build in data centers. There's the partnership with NVIDIA and OpenAI. But if we think about the capability of actually generating power in the US, there's only one reactor that can generate 4 gigawatts. And the others that are close, there's 3 of them. So if we want to add 100 gigawatts of capacity, or gigawatt hours, right, it's actually very challenging. We as within the US, I'm from Canada as well, we as a species, right, cannot generate this power this fast at this point in time, right? Especially in the Western world, right? There's been typically the assumption that power consumption will go down over time as we become more efficient. So if you want to scale exponentially, right, and that's sort of the claim made in situational awarenesses and other recent blog posts, you have to scale power exponentially, which is not trivial. If we think about this with regards to the claim, right, so we had this announcement from NVIDIA and OpenAI recently about deploying 10 gigawatt hours of power of chips. And then you have this claim of, or this opinion rather, from Sam Altman saying that we can do really great things if we have this much power dedicated to compute, and that's why we have to make that investment. Now, compared to software, right, deploying to 100 million people is relatively easy when compared to deploying power for 100 million people. So we just have to be aware of physical limitations, and this is where forming an opinion is important, is that sometimes the claims that are being made cross your domain of knowledge, right? And you have to do some more research or go talk to experts in the field, right? So now let's talk about a thought experiment, right? We have all these questions about power and AI progress and everything else. Assuming that you had one question you could ask, any question on AI, what would it be? And it wouldn't just be what, it would be to whom, what would be the question, when would you ask it, how would you formulate it? And I think this is really important to think about, is that what do you actually care about and what do you want to know, right? So, for example, you might ask, has AI solved this complex fluids equation, a generalized form of Navier-Stokes, right? So this might be a question that you ask to one of the heads of the AI labs, or when all of them are in a room. But I'm not sure it actually gives you something useful or something that you care about. It's a very big achievement because this is an unsolved problem in physics, but what are you going to do about it, right? At the same time, you might ask the question of, will there be mass white-collar unemployment in 3 years, and ask the same audience. And depending on this answer, right, this is a little bit more subjective. There's no objective way to think about it, but the heads of the labs might have a very strong opinion on this. So this is where the question of actually getting a confidential or potentially confidential answer or an opinion starts to walk the line of, am I just curious, or can I do something with this information? So that's where we get to part 2. We have asymmetric information because many things are confidential within companies and organizations. So if we go back and we think about what has happened in the past few years, there's been a lot of progress since ChatGPT, right? ChatGPT came out November 30th, 2022, and it's been almost three years since then. And people might say, okay, are we hitting a wall? Are we making progress? Here's just a few things that have changed so far. And even as I was putting together the slide, there's more things that have changed since, right? So it's actually hard to measure how many things have changed within the space. But when ChatGPT came out, it was actually interesting because GPT-4 was finished training before ChatGPT was released, right? So this was within the launch video of GPT-4. So the next generation was already available before we as the public even found out about it, which gives this question of how much do people know, right? Within the labs, what can they see? And this creates this level of mysteriousness or allure, right? Of they know something that we don't, right? And this gives a lot of clout or perspective to their claims because they have information that we don't have. So there was quite a bit of a delay between the training and the release, both for post-training and logistical reasons, right? But we can say that there's probably a 6 to 1 year lag, or maybe more, between some of the things in the labs and some of the things that are being released. And the reason that there's a lag, some of it is experimenting, some of it is for commercial reasons, right? You don't always want to release your best models if you don't have to. They might be more compute intensive or more complex, but this is where competition is useful, is that every time we notice that one lab releases a new model, right, the other ones quickly follow because there's pressure to innovate and stay relevant. So we look at some of these claims that are being made from the labs. So the Anthropic CEO said that within 3 to 6 months, 90% of code will be written by AI models, right? And within 12 months, it might be almost all the code. So we look back and the cynical perspective said, okay, it's been 7 months since March. My organization is not writing 90% of the code with AI. But the claim wasn't very specific, right? This claim might be based on the assumption that you're using best practices, you have a super clean code base, people are on board, you have access to the best models. So there is some asymmetric information here or asymmetric context that's being given. It is very possible that Anthropic and the other labs are writing 90% of their code with their own models, right? But we as consumers likely have not seen this within our own organizations and the complexity of problems that we work on. So oftentimes, one way to think about this is to think about, is this claim based on the best case or the average case? So in computing, we often think about worst case, right, when doing the analysis, but best case is also something to look at how people are making claims. Because in the average case, if you work at a large organization, your governance committee might not meet for 3 months, right? So let alone you being able to make coding changes within that time. So contrasting this claim about how much code is going to be written, we write a lot of code within the world, right, within large organizations, but yet 95% of organizations are getting zero return. The claim made by MIT's State of AI in Business report that came out a few months ago and sort of shook up the stock market in some perspectives, right? So there's a lot of investment. People are investing in GenAI. We're seeing these claims, and we're seeing the contrast of the actual results that we're seeing. And we can look at general products, right? How much AI are we seeing in the world that's making our use cases better? And we can look internally commercially of what we're seeing as well. Reframing this question, we often get asked, is AI making you more productive, right? Are you sending emails more quickly? Are you writing more code, right? Are you doing faster research and so forth? Now, if we compare this question with something that's slightly different, if we say, are your coworkers more productive, we'd probably get a very different result in terms of polling. Is the person who's messaging you with 3 pages of AI-generated code for a PR or PRD, right? Are they actually being more productive, or are they creating more work for you? And this is actually a technique in polling and other approaches that is used to reframe the question, because when we think about ourselves, right, we have a different perspective. So think about this as well, is think about how the world around you is changing, and not just your own productivity, because sometimes it's very easy to feel the gamification, right, of you're coding in an IDE and you're pressing tab, tab, tab. The AI is making you feel smart and productive. So it's not just your own productivity, it's thinking about an organization as a whole. And with this in mind, again, we don't have access to all the models, the compute, the resourcing that many of the labs have inside. So you just have to accept, right, that there are things that people working at the labs or building know that we don't, and try to take that into account when making these estimations. Okay, let's move on to part 3. So part 3 is, we have this information that we don't know everything, we're missing context, there's all these claims being made, so what should you do? So if you've read a little bit of philosophy, you might have heard of Pascal's wager, where the idea is that you have this matrix, right, of how do you believe in a higher being, how do you believe in God, based on if God is real or if you believe in God. So this philosophical approach leads you to say, I should believe in God because if I don't, there's a really bad circumstance, and if I don't, nothing happens, right? So with this in mind, this is kind of this logical approach, right, to do this, but it is flawed because there are still consequences in doing so that's not always captured by the matrix, right? You can make the inverse claim and so forth, right? Now, at the same time, we can think about it across the board for AI news as well, right? If a certain claim is real or AI news is real, how do you react? And if it's not real, how do you react as well? And what are the consequences of thinking or believing in the claim versus not? So let's go through a few examples. The first one is that LLMs make developers 10x more productive. Now, the comparison here is that sometimes we don't have access or the resources to do so. And the other part is that this claim might not be true. It might actually slow developers down. So you can think about all these things that you read or the claims that you care about and try to map this out, right? So if you don't have access and LLMs make you more productive, right, you have this FOMO, you're trying to panic and get in, right? But if you do have access and there's a 10x productivity, right, you would buy this technology and pay a lot of money for it to make it happen. And on the other side, right, if you do have access to technology, you should probably approach it cautiously because there's growth and improvements throughout time. And sometimes if you don't have access, you might be snarky about it, being like, hey, I told you so, right? So there's these decisions that need to be made and your mindset of how are you going to add an opinion or have a response to each of these quadrants. Okay, what if a new model is out? How should we react? So this one is about the new model coming out. It's in your field versus not in your field, and whether you read about it today or in 3 months. Right, so one of the things about all this progress is that there's this feeling that I have to read about everything, and you have to filter it in some kind of way. The benefit of learning about cool things in the world, right, is that it might produce some inspiration or your own work, and it might be intellectually stimulating. Now, if it's not relevant to your work, right, it's not as impactful. If it is, it might be, but it might not be the top priority. So as we know, as things get more complex, we need to start prioritizing our work quite a bit. Otherwise, the internet with 8 billion people creating content is hard to manage. Now, if you're going to take dramatic action on this, right, and you're like a very action-oriented person, if you read it today, you might say, wow, this paper is amazing. I'm going to change careers right now, right? That might seem like a big claim, right? But that might be a rational response depending on how big this new model is. You might have seen this, that when LLMs came out, people sort of completely pivoted their companies or changed careers to be part of it. If you wait 3 months, right, there might be more progress that's being made, and it might be easier to approach because there's more code developed and open source implementation or further improvements. So you need to think about, based on your own actions and your own personality, how are you going to react to all these changes? Because if you're not going to do anything about it, what's the point of panicking and having anxiety on it, right? So this is really important, where applying your own state of mind to these problems is important. So I'll give you an example. So this paper came out in 2024 about scaling LLM test compute from Google, from DeepMind, and then O1 on the reasoning side came out a month later. So I read this first paper, didn't think too much about it. O1 came out, but O1 was very expensive and hard to use, or not hard to use, different to use compared to traditional models. It didn't move the evaluations on a lot of the things that I was working on at the time. So the fact that I read the earlier paper by DeepMind did not matter, right? It took some time for that space to mature. The use cases I was building for didn't directly benefit. It was a very cool and interesting development, but it took some time and there were no immediate consequences. Now, I could have read that paper and said, hey, I'm quitting my job and I'm going to focus on RL and reasoning model and inference compute, and then it would have mattered. But that's not what happened, right? So knowing your own agency or your risk tolerance or your action is really, really important to calibrate how much you should care about certain topics. And sometimes you can be wrong. Like I thought ChatGPT wasn't going to be a big thing compared to GPT-3, but I was completely wrong, right? So you need to be able to adjust your opinions and have a good peer group to make those decisions. So I think what does matter is focused effort. People sometimes want to read 1,000 papers or skim through them and know a little bit about everything. But I think what's more important is picking a few works and understanding how much understanding certain domains is going to help you. So this is a paper I really like to talk about. It's the paged attention paper. It has a slightly different name. It came out in 2023, and it compared the areas of operating systems to improving the KV cache and LLMs. Now, I really like this paper because it combines various areas of computer science and technology, right? But what's also really interesting is that anybody who was fairly comfortable with LLMs and operating systems at the time could have written this paper. So it was possible with enough effort to make this large contribution to the space. So when I teach students, I teach a ML engineering class at U of T, I reference a few of these papers to say, hey, if you understand these different domains and you have a spark of inspiration, you can make a change in the industry. And it's not that you need to have certain proprietary knowledge to make this innovation. So that comes to the idea that if you care about certain areas and you want to learn about them, it's much more important to deeply understand something, be able to implement it, talk about it, because the amount of people who actually know that domain is exponentially smaller than those who have skimmed through it and just vaguely thought about it. So going deeper is much more useful, especially if you want to commit to a certain area. There's so many of these papers that I've read that are super interesting research areas, but there wasn't too much work done on it initially, right? For example, text diffusion models, constrained decoding, optimizations at the hardware level, right? Flash attention came out with some of these ideas as well, right? So think about where you want to make an impact, and you can actually onboard very quickly and get very good based on these specifics, right? And it's actionable and it feels good and it benefits your career over the long term. So this is the question, right? So how will AI news affect you? You need to think about this reflecting on your own knowledge, the impact of what you read, what you think about, and filter what's out there, right? Because there's so much information that you need to have a plan. And you can work with your peer group, mentor, whoever, to form that plan. But if you're just consistently panicking about how quickly the world moves, right, it's not very constructive. So the overall takeaways and my strategy is to read a variety of sources to form an opinion on these things, right, from the AI news to the product launches and so forth, right? This is important in general media literacy. Having a good peer group to discuss. So we're excited that you're all at this conference, right? I think there's some great people to chat with. Comparing historical trends, right, with claims made 5 years ago, 2 years ago, and so forth, and see how they hold up. Understanding exponentials and both what they're capable of and what is required of them. And finally, to keep thinking and take actions that are proportional to what you want to do. So with that, I'd like to wrap it up. Thank you, everybody, for joining. We're going to have an exciting conference for the next 4 days. So keep learning, keep building, and don't be overwhelmed by the change. To make a plan, take the actions, and go forward. All right. Thank you, everybody.
I'm going to get to Amit's question in a minute. Thank you, Amit. I also have a question. Is there a way that you personally categorize, like any systems or any trackers? Because I know you are doing LinkedIn Live courses, you're teaching at the university, you're also running a team, running a startup yourself. So, I mean, you are drinking from the proverbial fire hose. How do you, on a personal level, take something and maybe flag it and try and categorize it as urgent, maybe keep an eye on it maybe next 3 to 6 months, or not really relevant for my industry or for what I'm doing, perhaps?
Yeah, it's a great question. I think I'm in the fortunate position where I do these things that excite me, teaching, building, leading a team. So with that, I get exposure to different aspects, right? So the topics that I teach about are very different than, or semi-different from what I do every day, because it's structuring it for fourth-year students, the skills I think that are important for them, and some sort of theoretical and practical background, right? So even though it's not related to my job, I get some exposure to that, and I'm thinking from the lens of, if I'm building a curriculum, what would I want to know many years ago, right? And what would be important? So that gives me one lens. The LinkedIn Learning content gives me a lens. It's focused on sort of a general learner within a company. So assuming that hat and saying, okay, what would I want to teach in that environment? And then at work, there's the deliverables there. So there's always going to be things that I miss, but with those sort of 3 areas and sort of spending so much time within it, right, or prepping talks and so forth, right, I feel I get enough coverage within that. But more generally, I think it's just making that list of goals, right? Do you want to pivot into a certain area? Are you seeing certain trends? If you interview 50 people and you say 45 think that this is important, right, it might be true. So I think the system is just have a goal, know how you react, how much risk tolerance you have, and make bets based on that.
Thank you so much. Amit is asking, could you share which papers you read, or perhaps the data sources, and again, how you select them? You've kind of gone over that, but anything that comes top of mind? Is there, I mean, you get things from LinkedIn, from Twitter, there's Archive, there's all these sources. Are there any ones that you prioritize or that help you immediately prioritize, which is an initial filter, perhaps?
Yeah, I mean, the takeaway from the talk is that I'm not going to share that, because everybody should have their own goals, right? Like, there are lists of like important papers, there's researchers to follow, but the exercise is think about a topic that's important to you and go through with that, right? Because I think it's very easy, even with reading papers, it's just like a dopamine hit. It's like, oh, I feel smart today because I read this paper, right? So the approach is figure out what your goal is, figure out what's important to you right now or in the future, and then you can search, right? You can search Archive. There's other sources to search. You can interact with LLMs to go through and get a list, but just broadly saying, okay, well, I want to learn about diffusion today, right? Well, why do you want to do that, right? So there's something inherent to curiosity, but there should be a plan. Otherwise, you're just going to go in circles and be overwhelmed. So,
as a founder, a great question. As a founder, who wants to potentially raise funds, get some attention, get some momentum for their startup, are there any conferences or journals you can recommend?
I think, I mean, it depends what you're trying to do. If you're trying to generate marketing hype versus building scientific progress, right? Those are very different goals. So, I mean, Archive is great just as a place people know that they can search and such. But if you're trying to fundraise based off an idea, right? The broader marketing channels or speaking to VCs directly about the content, I think is a better approach. And then you can have your technical blog or list of papers to reference to say, hey, our team has technical capability to verify what we're doing.
Thank you. Any personal, I guess this is a personal question, but you've picked up a paper, you determined that this is worth your time. Any approach to actually consume that paper? Are you skimming it first? Are you reading the initial thesis? Are you reading the end? Any personal things that work for you?
Yeah, so I go through, read the abstract, read some of the key results. If it's a very interesting paper, sometimes if it's older, I try to search YouTube to see if somebody has done an overview, just because they often take some of the hard ideas and narrow it down. But it really depends. Some of the papers are super theoretical, and I'm like, oh, this is interesting, but I'm not going to dive deeper into them. Some of the papers that, for example, have inspired some work or we've re-implemented, those ones are like you go through and you just write code. You try to reproduce it, and that's actually a very valuable skill to reproduce a paper, which goes to that point, right? Reproduce 3 papers, that's much better than just skimming through 1,000 papers.
Fantastic. What's the role of citations in helping you determine if it's a worthwhile piece of work?
So this is a great question. So a little bit of a story. Last semester, I was teaching probabilistic machine learning course, and one of the ideas I connected together for the students was LLMs and diffusion models. And the LADA model had just came out like the 2 weeks before, and it had 1 citation, right? But it was an interesting idea to say, how do diffusion models connect with LLMs? A few months later, Google published an idea on it. So there's always examples or counterexamples where citations are useful or not. I don't know what the paper was at, but when I included it in my course material, it hadn't been peer reviewed and it had 1 citation, right? So there is a clear purpose of including that paper. Other papers have a lot of citations, but they're not particularly, they're sort of foundational that every paper references, but they're not necessarily going to give you that much information, right? So for example, Adam W has a whole bunch of citations and it's great, but it doesn't necessarily change how you behave if you know how the optimizer works, as opposed to there are other papers with way fewer citations that will inspire your direct work, and there might just be fewer people working on those problems. So it really depends.
You mentioned something really interesting in your presentation, and then we'll wrap up in a minute, but you kind of differentiated between being productive as a solo unit, sort of upstream. So I've been able to tab, I have a ton of code, and now I'm pushing it, maybe somebody's reviewing it, and they have suddenly 3 huge swaths of code that they're reviewing, let's say, as an example. So it's not so productive downstream. Do you look at this as an issue, or how are teams approaching this, or how can teams approach this when somebody might feel like they're being much more productive, but as a unit as a whole, you sort of clunking up the process downstream?
Yeah, this is looking at things as a team or as a unit where we work in teams, right? As people, we work in teams, whether at startups or research or other organizing aspects. So I think there needs to be ways to measure productivity, right? In software development, we have things like Dora or other metrics. But I think it's just, again, chat with your team. If somebody gives you, it's like that meme, right? You use AI to write your email, somebody uses AI to summarize it. Okay, what have we done, right? So I think every organization has its own set of metrics, but there's definitely a few talks out there talking about team productivity on it. So take a look at those. That's its own area of research and topics. But yeah, just just think about the impacts as a whole, right? Both within your team and society as well. So.